Assalamualaikum and good day, Miss Nia. Today, our group will present the Maritime Relief Route Optimization System. My name is Nazakira Maisara and I will be explaining the greedy algorithm. The greedy algorithm solves the traveling salesman problem TSP by always choosing the nearest unvisited location at each step. It is simple, fast and suitable for emergency relief situation where quick decision making is needed. So here, at the Java implementation, we define the distance matrix and location. The distance matrix stores the distance between each point in nautical miles, while location array contains the name of port and relief center. So here, the greedy algorithm is implemented in the method greedy TSP, and then I create the visited boolean array and start at port A by marking index 0 as visited. Okay, and then the main part is the loop, which is this loop run to find all remaining location. Inside this loop, we initialize min days equal to integer max value and net city equal to -1, which is this mean we are searching for the nearest unvisited city. And then we check all cities using this code. If the distance is smaller, we update the net city. Once the city is found, we mark it as visited, add the distance, append it to the route and move to the current city. At here, after all cities are visited, we add the distance back to the starting point, and this code will print out the output, which is the output is this. So the final greedy route is start with port A and then go to port B and then relief center D, relief center C, and back to the starting point, which is port A, and the total distance for the greedy TSP is 88 nautical miles. So the greedy algorithm have advantages and also disadvantages. So the advantages of greedy is that it is extremely fast and easy to implement, which is useful during emergency operation. However, the disadvantages is that it does not always guarantee the perfect optimal route because it only focuses on the nearest next step. So for the conclusion, the greedy algorithm provides a quick, simple and effective solution for the route planning in our maritime.
Hi everyone, my name is Akila, and in this section I will briefly explain how dynamic programming is used to solve the relief route optimization problem or RROP. For dynamic programming or DP, is a method used to solve problems by breaking them into smaller parts instead of calculating the same thing again and again. DPs have the answer and reuse it. This helps us to solve complex problems more efficiently, and it also ensures we get the best answer and most accurate solution. So, how dynamic programming is work? The idea is, first one, choose the starting point. Second, look at all subsets of city. And third, store the shortest route to each subset. And the fourth, use this store result to build the final optimal path. And this method guarantees the minimum distance. So in our Java program, we use a dynamic programming table with bit masking to keep track of which city have been visited. We fill the table with the shorter cost for each state, and finally we construct to the optimal route. It's more complex than other methods, but it gives us the true optimal solution. So for the advantage of dynamic programming has a clear strength. It always gives the optimal route and it avoids repeating calculation. While the advantages of dynamic programming, it also has limitation. It uses a lot of memory and it becomes slow when there are too many locations. So in conclusion, dynamic programming is one of the most accurate methods for RROP. Even though it requires more resource, it's very important when delivering relief supplies because the shortest route can save time and life. So that's all from me for the dynamic programming.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Safia, and today I will be explaining the backtracking algorithm and how it is used in solving the relief route optimization problem or RROP. The main goal of this algorithm is to find the shortest possible route that connects all ports and relief centers, ensuring that it is delivered efficiently and on time. The backtracking algorithm works by exploring all possible delivery routes one by one. It starts from the main port, which is port A, and visits each relief center recursively. At every step, it adds the next location to the route and calculates the total distance. If the distance becomes longer than the best route found so far, then the algorithm will backtrack or go one step backward and try another possible path. This process continues until every possible route has been tested, ensuring that the optimal route with the shorter distance is found. In our project, this algorithm successfully discovered the shortest route, which is port A to port B, and then to release center C, and then to release center D, and lastly to port A with a total distance of 88 of 90 nautical miles. Okay, one of the biggest advantages of backtracking is its accuracy. It always finds the optimal solution because it evaluates all possibilities. However, the main limitation is that it's very slow for larger datasets since it checks every route combination, which means its time complexity grows exponentially. So while it's perfect for small-scale relief operations, it's not ideal for larger systems with many routes or destinations. So, in conclusion, the backtracking algorithm is a powerful method for achieving precise and reliable route optimization in Rrop. Even though it requires more time and computation, it serves as an excellent benchmark algorithm to compare the accuracy of faster approaches like greedy or dynamic programming.
Assalamualaikum, my name is Fidauzi and today I will be presenting about divide and conquer as well as sorting and searching algorithm and also the Java implementation code of the two algorithms. Divide and conquer is a technique that solves a complex problem by breaking it into smaller subproblems and then the results are combined to produce the best solution. The three main steps are divide, conquer and lastly combine or merge. In our Java implementation code, here we have our first method. Inside is the declaration of all variables, and then we call the method divide and conquer helper to begin divide and conquer recursion. Lastly, we have the code to return the final output. Next, we have the base case, which is the method divide and conquer helper. Basically, this code is to check if all locations are visited, compare for the best solution, and lastly, update the best path. Next, we have the recursive case. This code is to explore the next level of the path, update the current node, and continue exploring. And then we also have, inside of it, we have backtracking, which is to remove the added location name from string, and then mark the location as unvisited again, so that the algorithm can try a different location in the next loop iteration. Lastly, we have private static boolean all visited. This method loops through the visited array and returns false if at least one location has not been visited, and returns true only when all the nodes are visited. Next, we have sorting and searching algorithm. Sorting algorithm is used to arrange data in a specific order. Searching is the process of finding a target value inside a dataset. First, we have the sorting and searching TSP method. Inside, we call the insertion sort method and also the binary search method. Next, we have the coding for the output, and lastly, to return the results. Next, we have insertion sort method. This method sorts an array in ascending order. It starts from the second element because the first is already sorted and the current value is inserted and compared backwards. The purpose of while is to shift the elements greater than key to the right, and lastly insert key into the correct sorted position. Then we have the binary search method. The first code is to initialize search boundaries. The algorithm calculates the middle index, and then the value at this midpoint is then compared with the target value. If the middle element is equal to the target, the method immediately returns the index. If the middle element is smaller than the target, that means the target must be in the right half of the array, so the left pointer is moved to mid plus 1. Otherwise, if the middle value is greater than the target, the search continues on the left half by moving the right pointer to mid negative 1 or minus 1. The loop continues reducing the search range by half each time until either the target is found or the range becomes empty. If the target is not present in the array, the method returns negative 1. Finally, we run the program to see the results. If we press on divide and conquer button, it shows the result, which is port A to port B, and then to relief center D and relief center C, and lastly back to port A. It also calculated the minimal total distance, which is 88 kilometers. Then for sorting and searching, sorted array using the insertion sort is 1, 2, 3, 5, 8, 9, and then we have the binary search array, which is also using the sorted array 1, 2, 3, 5, 8, 9. The target is 5 and it is found at index 3. In summary, divide and conquer helps my system explore and identify the best relief route, while sorting and searching help organize and retrieve data efficiently. This algorithm work together to improve performance and decision making inside my maritime relief route optimization system. That is all from me. Thank you.